between vectors. Let us say that we have a couple of vectors. We have vector u, which is defined by u1i plus u2j plus u3k and we have a vector w. That wasn't the right thing to do. Hang on. Why can't I undo that? Okay. Oh. No, it's still going. Okay, so we got two vectors. These will be in 3 space. Okay, which is the space that we inhabit. So we have I, J, and K mutually perpendicular, right? So it could be, you can imagine that we have a plane running along the top of your desk. That would be I and J, I to the left, and J into the board, and K straight up, right? Sure. So these I, J, and K are all mutually perpendicular, or orthogonal. Throw a word there. What is the magnitude of u?
The square root of u1 squared plus u2 squared plus u squared plus u3 squared. You have to find the modulus of it.
And what is the magnitude of w?
Square root of w1 squared plus w2 squared plus w3 squared.
These are just numbers. w1 squared plus. Okay. What is u dot w?
U times w equals
u1 w1
plus u2 w2.
plus u2. You going? You're not. I'm not going there yet.
u2 w2 plus
u3 w3. Right. Let you copy stuff down. If you're copying stuff down, move this down a little. What's u dot u?
times u1 or u1 squared plus u2 times
Which could also be expressed as
u1 squared plus u2 squared 3 squared, which looks similarly like the magnitude.
which looks a lot like the magnitude, only it's what?
Not rooted.
Or we could say that u dot u is equal to the square of the magnitude, right? Okay? So what could we say about w dot w?
w1 squared plus w2 squared plus w2
Skipping ahead to the end.
magnitude of w squared.
Okay? We're going to get there eventually. We might as well get there right away. All right, so we have this so far, right? From what we have learned to this point. So we have two vectors, u and w, in 3 space. The magnitude of u is the square root of the components squared, sum of the squares of the components, and the same thing with w. U dot w, the dot product, is defined as u1 w1 plus u2 w2 plus u3 w3. If we dot u with itself, we find out that u dot u is really the magnitude of u squared. And w dot w is magnitude of w squared. Okay? Ready? We're going to move on.
Yeah.
Okay. So let us say that this is vector u, and that this is vector w. Okay, so, wait, now I've got to erase that. Okay, we got vector u, we got vector W, and we got this vector, which I am drawing which way? This way? Okay, and what vector is that? That's U minus W. Because U, this, plus, but I got to turn this around, right, if I want to do tip to tail. So plus, and I'm going to how do I turn something around? Make it negative.
Additive inverse.
Okay, so what's that equal to, right? It's U plus minus U plus W, which is equal to W, right? Which means that this is correctly named, right? That this is the vector U minus W. Because when I take this plus, flip that around, I get that, right? Okay? Right, so, now,
what do we do with this?
what do we do exactly? That's what I'm wondering. So now, what do we do with this?
Are we supposed to do math?
We'll do math with this.
Oh my god.
Let's do some math with this. So let's say that I now take the magnitude of U, the magnitude of W, and the magnitude of U minus W. I should have just used A's and B's. Okay? And let's say that there is an angle between them, right? Because now that they're magnitudes, they're really just lengths, right? They're just, so something has, it's a triangle, right? It's just a triangle. And yeah, how do we find theta, right? So we go back and we think about our law of cosines. How would you like to name this? I don't know. So A, B, C. So there's theta. So this is little a, little c, little b. What's cos theta? Well, okay. What's this? So the law of cosines is what? C squared is equal to?
A squared plus B squared.
Right. So if it's 90 degrees, you stop there, but it's not. So then we
Minus 2A minus 2A equals the
cos c.
cos.
Or theta or c, whatever, right? Okay. So that's law of cosines. Let's take that. Let's apply this to this triangle here.
Oh my god.
So what will it become then, right? So what's little c over here? Magnitude of u minus w squared is equal to, what's little a? Well, let's just stay in alphabetical order, right? Magnitude of u squared plus magnitude w squared minus 2 times magnitude of u, magnitude of w, cos theta. Okay? I'll let this sink in for more. You can copy it down and then just think about it, let it sink in a bit. Okay? So we're just using the cosine law, right?
We also have the dot product.
Cos c is a squared plus b squared minus c squared over 2ab. Just the rearrangement of that, that's all. I mean, it starts off as c squared minus a squared minus b squared over a negative, and we get rid of the negative, and then it becomes a squared plus b squared minus c squared. Not much to do with this. Okay, so based on the magnitude of squared of something is equal to what? Dot product. Eh?
Oh my.
So we are going to go through and replace the magnitude of this squared with a dot product. U minus W dot U minus W is equal to the magnitude of U squared plus the magnitude of W squared minus 2 times the magnitude of U, magnitude of W, cos.
Shouldn't we replace
No,
Cos theta.
no,
What? No.
no.
What are we talking?
What?
What's the question?
No,
What's the question?
no.
No.
He wants to replace these.
Oh.
No,
No.
no, there's a reason.
Oh, no.
You'll see. Patience.
Especially not
Patience young.
Especially not.
Okay.
It's not me
So,
anymore.
dot product is analogous to multiplication, has a distributive law. So we get U dot U minus U dot W minus, and it's also commutative, so I'm going to go another U dot W plus W dot W. Okay? That's just foiling that out, right? That's all we're doing. And that's equal to.
That thing. You just say that thing.
No, we write it out because we don't get lazy and stop writing stuff.
We don't?
I do.
Oh God. Oh God.
Yeah, I know. Well, not if we don't want to lose the associated marks with that.
I like how.
Okay, what?
On one lot of people.
What is U dot U?
Square. Wait, you don't. Magnitude of u.
What is U dot U? The magnitude of U squared.
Which is why we kept
Too far.
Which is why we kept it.
So, magnitude of U
Makes too much sense.
squared
It makes too much sense.
minus 2 times U dot W plus magnitude of W squared.
So cos of beta equals 0?
Well, you have to put a vector arrow on top
No,
of
no,
the
no,
u.
I'm fine.
Don't leave it.
Okay, yes.
On the test, can we skip those two middle steps?
No.
So,
Can't skip any of that. We're just going from that straight to
I
that.
think you meant the foil.
That? No.
huh?
Alright, what are we going to do to simplify this?
Cancel. Cancel. Cancel.
What are we left with?
What? And then you get the same thing as we had at the beginning. Oh, never mind. So it seemed that it's two back.
We derived the formula I gave you the other day. Right? We did two formulas for dot product, right? U dot W, U1, W1, etc., etc. And we also gave you, this is the proof of that.
So what did this accomplish?
Oh, so this will be a test.
We developed the formulas. I'm not going to ask you to develop the formula.
You said
I'm
that
gonna-
quadratic except for the then. What's on the test?
It's not on the test, don't teach it to us. We don't want to learn anything that's not directly related to the test.
That's how the world works.
Because we only have so much capacity and
It's true, we're running out of IDs.
and it's May and we're running out. Hey, next year in May you'll be a little more stressed. You'll be writing exams. Right? You will not be writing HL Math next year. You write HL Math in grade 12. You will be writing SL Math next year if you're doing SL. You need that back? Okay. So all this is just a proof of that other form, right? So we can find the angle between two vectors. So now let's find the angle between two vectors. Okay? And let's do this with some numbers, right? Numbers are good. Actual numbers we can actually find stuff for. Now, this formula works in multi-dimensions, right? Most of the stuff we're actually going to do in vectors is going to involve 2 dimensions and occasionally the odd 3 dimension, right? But this applies to 4, 5, 6, 7, 8 dimensions, which is when you just get into drawing column vectors, right? You're never going to do J's, I's, J's, K's, L's, M, right? You just go straight to a column vector and you just list, U1, U2, U3, U4, U5, all the way to UN, right? So that you can do this in general for n space, which you're not going to be required to do. Okay. But you might be required to do this.
See, this is what every subject is doing.
Determine the angle between lines PQ
I don't know, I just felt like that.
and RS. I suppose I should draw little line arrows above those, eh? Where? Okay, so being as this is in two space, right, or a coordinate plane, right, then we should be able to sketch it out just to sort of give ourselves an idea of geometrically what does this look like, okay? And a lot of the stuff that we do with vectors, we have other ways that we can use coordinate geometry to do a lot of stuff, right? Because if we're mostly working in two space, then, but what you have to understand is this scales up, right, to 3 space, 4 space, 5, you know, and beyond, right? And there are uses of that in real life. Okay, which you may end up using, okay, to describe things, to model stuff. Okay, so let's just sketch this out, right? Let's just get an idea. Okay, where are these lines? What do they look like? So P is at 1, 2. Doesn't need to be exact, but it should be at least relative to each other. So I should put P in the upper right quadrant. You know, so there's P at 1, 2, and Q is at 6, 4. So that should be like further out this way and here. So there's PQ. So the line PQ goes like this, right? So there's PQ. That's 1, 2, 2. That's 6, 4. And the line RS starts at 4, 1. So 4, 1. And goes to 7, negative 1. So
How do you know where the vector starts at PQ?
use the letters, man.
But you'll just like, or do like a line like beyond the point.
Yeah.
Is your line extended?
The line PQ. The line goes both ways. But it's directional, right? Because it's going from P to Q. If I wanted QP, it would go the other direction. Remember, vectors have direction. I can't just go throwing a line on. Okay.
This is the time where you don't put arrows everywhere.
Not everywhere.
And then RS.
You missed an arrow.
Yes, I did. And I just explained that.
Oh my god.
Okay, so we want to find the angle between PQ and RS, which is where? Here, 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 or here? Last one. Okay, so we're going to be finding this theta here, right? So how are we going to do that? Well, we are going to use vectors, right? So we will call U, vector U, will be PQ, and is what? Give me a U in terms of I and J.
P, I, 6x is 4.
I don't know how you get from P to Q, but let me tell you, for me to go from P to Q, 5I.
Yeah.
Oh, okay. Oh,
Oh, I was right. Oh, what?
why are you so mean to me then?
Right? Okay? So vector U is going from P to Q is going 5I plus 2J.
I'm all the gay stuff.
Vector W. Call it WW.
Oh, 110 over. Oh.
Equals RS. And what's RS?
3i minus 2j.
We're doing RS or SR?
RS.
Okay, I don't know. Okay.
3i plus 2j. Plus 2j.
3I.
Minus 2j. Wait, oh yeah.
That's no normal.
Okay? Alright, so what do? Well, we say, hey, I've got a formula, and that formula says that U dot W is equal to the magnitude of u
times magnitude of
times the magnitude of
times
w
cos theta.
times the cosine of theta, which means the cosine of theta must be equal to
X.
Times V divided by.
U times V over U. Magnitude of U.
their w's.
Oh, sorry.
Oh, what?
Double root.
Oh, W. Oh, yeah.
Say vector.
Vector.
Vector, yeah, that's how it comes out. Vector. I'm going to see Star Trek. We'll see if he says vector. Victor, Victor. But that's not for 2 weeks, so today I'm going to see Iron Man. Oh, Iron Man. Got tickets, 4:35 show, Ultra AVX.
I bet it's gonna be like Iron Man 2 and 1. It's gonna be some guy making an Iron Man suit fighting Iron Man.
Okay. U dot W. Oh, I've hidden numbers. U dot W. They're still sort of semi-hidden.
5x.
U dot W.
5x plus 2j times
5 times
3 15
plus
plus 2 times negative 2 minus
2 times negative 2. Stop there. Over the magnitude of U.
oh god, it's gonna be long after. 5 squared plus 3 squared.
2.
I see it too.
Yeah, it's 2. It's 2.
Okay.
Oh, crap.
Times
Times the square root of 3 squared. And then minus 2 squared. Or 2 squared.
Okay. So you got all numbers. You see where all the numbers came from. Right. We're doing U dot W. It's U1 times W1 plus U2 times W2. When we're doing the magnitude of U, it's the square root of U1 squared plus U2 squared. Because it's a dot.
Same thing.
It's a dot. Because there's a thing called the cross product, which actually uses the multiplication symbol, and we don't study it
Why?
because we don't.
We're too dumb for it.
You're too dumb for it. No,
I'm hurt.
it's not in the curriculum. Okay? That's the, you're more than capable of getting it. It's just not in the curriculum.
It's IB, and IB says no.
HL math.
You don't.
No, probably not.
Did I have it?
You should just take it away and we go to the back.
You can look at it.
Ow!
Okay. So what is this?
15 minus 4.
11.
I divide by square root
1 root at a time.
29. Root 29.
Root 29. Root
Times 13. Root 13.
13.
No what?
Okay. So what's theta? Cos inverse of that. That's actually what I was looking for. Yeah. So what's theta? Rounded to the nearest, I don't know, let's go 100th.
Degree mode.
Degree mode.
Oh, degree mode.
Let's put into degree mode.
Divide by cos.
Second function cos.
Eddie,
11
divide by cos.
divided by.
This is too much work.
Yeah, I've seen your tests.
Oh god.
55.491.
55.49. We'll just go with 2.
Hey,
That's
this is hundreds. I gave it to hundreds. Don't blame me.
Well, you said 491.
Oh wow, I'm dumb. Oh my god.
I was willing to stop after 2.
Okay. Oh god.
Here, we may have to work on tenths, hundredths, thousandths. Yeah.
No English.
Numerical response, never 3 decimals, not possible. They only give you 1 to 2. Okay, so. Yeah.
All that.
All right, so now then, what about
This looks a lot like why that's active.
Oh, 55.
What if we do the angle between PQ and SR?
Yes, because
Really?
then it becomes,
Is there a
then it becomes
Well,
top left one.
where's SR?
It's going the other direction.
What's the angle between PQ and SR?
Oh, I thought we already did that song.
Be that angle.
We did our ass.
180 minus that?
Yeah, it's 180 minus
We did this angle. We did the acute angle.
180 minus the original thing.
Now we're going to do the not acute
90
angle.
minus whatever.
You can do 90 minus whatever. I would prefer to do 180 minus whatever,
Wait,
but
no, no,
180, not 90.
Derp.
This video, remember, that's the one.
but hey, doesn't hurt to have a little practice. Let's just work this from scratch, pretending that we don't know that they are what kind of angles?
Oblique.
Starts with an S, ends with an entary. Supplementary. See, your English came back.
Oh, transversals, right?
What's PQ? Same as it was over there. What's SR?
Same as a B. Minus 3 plus 2J.
Okay, so
Ooh, quiet.
a needle pulling thread. So, it got real quiet.
It's because we don't.
So all we do is reverse the direction on this, right? So it's negative 3i plus 2j. All right. So let's just run that through the methodology, right? Which says what? U dot W is equal to?
Negative U times negative W times cos.
Okay. So cos theta is equal to?
Remember these formulas? Do we actually? What?
So the question was, do you have to write the formulas up? The answer is what?
No, do you need to memorize it?
Oh, you need to memorize formulas. For IB, never. You should see the formula book you got. As a matter of fact, do you want to see the formula book you got?
Yeah.
All right, hang on. Pause. U dot W.
I finished that right now. Where's my?
What's U dot W?
No, I was using it.
And what's the magnitude of U?
Square root of 5 squared plus 2J. Pretty similar. It's a 3 squared. It's a bit. Plus 2 squared.
This going to be any different than this?
Not really, no.
Not at all. It won't be different because we're adding the squares, right? It's the sum of the squares. It doesn't matter which ones. And what do? We just change the signs on. This is different, right? But the bottom won't be. Okay, so that's equal to, what do we got? Negative 11 over root 29, root 13. And what's theta?
Cos inverse.
And what's theta? Too many ones.
55.4.
Which is
24.51.
big non-surprise because we knew they were supplementary angles, but we've done it and shown it, right?
You can use that word.
Okay, so you see, look, it actually does work, right? That angle actually is the supplementary angle to that. Why? Well, what did we end up doing? We ended up changing the sign of the upper term in here, right? Bottom term's got to be the same because it's just the sum of the squares, and we changed the magnitude. All we did was change the sign. Okay, you may now do angles between vectors.